Now essentially this is a salt preparation method where you are required to come up with the procedure for a method to prepare the salt lithium nitrate. Okay, however there are many foreign concepts in this question which we will go through one by one. The first foreign concept would be the term hydrated. So what does hydrated lithium nitrate mean? Now before we go any further, I just want to point out that the term hydrated appearing before a salt has no effect on the method, has no bearings on the method to be used to prepare the salt. Okay, so when you see the term hydrated, you can just ignore it. It doesn't affect the method for preparing the salt. Okay, so what does hydrated mean? Now salts are ionic compounds. So when the salts are formed, the ions would come together and arrange themselves in what we call a giant ionic lattice structure. Okay, we have learned this in our chemical bonding. Now sometimes when the ions come together to form the giant ionic lattice structure, what can happen is that we can have some small molecules of water that are trapped within the lattice. Alright, they are not chemically bonded, they are just trapped within the lattice. Now these water molecules, we give them a special name, we call them water of crystallization. Okay, so in an ionic compound where it contains water of crystallization, we call it a hydrated salt. Okay, now bearing in mind that these water molecules are just simply trapped within the lattice, they can easily be removed by heating. So what happens when you heat a hydrated salt is that the water of crystallization will be removed, alright, and then the resulting salt do not contain any water, and then we say that it is anhydrous. Okay, a very famous example in the syllabus would be that of copper 2 sulfate. Now copper 2 sulfate, if you obtain the crystals, they are usually blue, and they are blue because it contains water of crystallization. Okay, now how do we represent that in the formula? Is that we represent it by a dot following the formula of the compound. So we have a dot and then H2O. Okay, the 5 over here tells us that on average, for every copper and sulfate in the lattice, we have 5 water molecules that are trapped in the lattice. Okay, now is it necessary to know how many water molecules are there on average? The answer is no. So if need be, we'll give you in the question. Alright, so otherwise most of the time we don't know on average how many water molecules there are. So that's the reason why you see an X over here. X represents a number, alright, and we have no idea. We are not interested to find out what is the value of X. Okay, so we just put it as X. So what happens if we heat hydrated copper 2 sulfate is that we'll end up with anhydrous copper 2 sulfate. So the water molecules will come out, and then this anhydrous copper 2 sulfate is actually white. So this is the very famous example that you need to know in our syllabus. Alright, so we have addressed what is hydrated, we have addressed the presence of an algebra symbol in our equation. Now let's try to answer the question. So how do we prepare lithium nitrate? Now that itself is very tricky. Okay, why? Is because we are familiar with the term spar salts. Now spar essentially does not just include sodium, potassium and ammonium. Okay, it doesn't just include these three. Alright, why we use spar is because it is easy to remember. However, if you take a look at sodium and potassium, they actually belong to group 1. Okay, so spar essentially is a short form for group 1 and ammonium. In any context, I know you have seen spar coming out many times, Alright, SPA essentially means group 1 plus ammonium. Okay, so what other group 1 metal ions are there? The most common one that you would see would be lithium. Okay, there's also cesium and there's rubidium, which are less common. So when you see lithium, cesium, rubidium, they fall under the category of SPA. So in this case, lithium nitrate is actually a SPA salt. Okay, therefore we need to use the titration method. Okay, so for this question, what you need to do is you need to write down the procedure step by step, what you would do in a titration method to produce lithium nitrate. Okay, so for example, you can actually put lithium hydroxide in the burette, and then you can put nitric acid in the conical flask. So you need to perform two titrations. The first time with indicator to find out how much what is the volume of hydroxide required, the titer value, alright, and then repeat the titration without indicator to prepare the salt, and then you perform a crystallization to get the crystals. Now a common question would be, does it matter whether the acid goes into the burette or the alkali goes into the burette? The answer is no. There is no difference. There's no preference as to which one must go into the burette or pipette. The only slight difference would of course be the color change of your indicator. Alright, for example, in this case, if I place nitric acid in the conical flask and I use methyl orange as the indicator, the solution for it will change from red to orange. Okay, in the event where I place lithium hydroxide in the conical flask, then the color of the indicator would change from yellow to orange. Okay, but both methods would work, whether you put the hydroxide in the burette or the conical flask.